Hi, this question is about the traveling wave in a string, which is transverse in nature. Because if you see from the diagram that the string is vibrated by moving it up and down, so that a wave will travel with a speed of 40 meter per second in this direction. So each and every particle of the medium will actually execute this motion up and down, whereas the wave is going to travel in a forward direction, just like you see in a diagram. So that's the time period is 5 second, 5 millisecond. And in this question, you have to find out the phase difference between the two particles, which are how much distant apart. They are 0.050 meter distance apart on the same string. There are the numerous amount of particles which all are executing SHM, simple harmonic motion, by moving it up, down, and the wave is traveling to the right. So I will show you the two techniques. The one, the very easy and the very direct method, and the second is from the diagram, which is going to be very useful. And especially at the end of the video, I will show you what it means for those two particles which are executing SHM. So I will show you their motion. So first of all, let's start from the direct method. So if you want to find out the path, the phase difference, so this is a equation 2 pi over lambda multiplied by the x. Now the x is a distance between the two particles, and this equation is always useful, always applies for this type of coherent wave whose time period is constant throughout. So the let's say the 2 points, the first point is at here, right? And the second point, wherever it is, the distance between them is 0.050 meter. Now we need right now the wavelength, and the wavelength is equals to the speed of the wave, of the traveling wave, divided by the frequency, right? Which you can obviously write like this: v over 1 over time period. So you can say lambda is equals to v multiplied by the time period, and the speed is 40 meter per second multiplied by 5 milliseconds. So 5 multiplied by 10 to the power negative 3. So, dear students, that is going to be 0.200 meter. This is the wavelength of a wave. So now let's plug the values in the equation, multiply by the distance between them, which is 0.050, and obviously that is going to become 2 pi, because this is, if you divide it, it is 4, right? So the answer is 2 pi over 4, which is equals to pi over 2, which means that those two particles are at a the phase difference of 90 degrees. So that should be pi over 2 radians. So the right answer is option B for this question. Now let's talk about the second method, which is from the wave diagram, right? It is going to be more useful for, because many students do not know this method. Now, so if this is a one complete wave, which I have just shown you, and we know that now their wavelength is 0.200 meter. So if this is lambda, then this is a half wavelength, which means 0.100 meter. And then this point is exactly lambda by 4, right? So it means that if I am considering the one point, the one particle is at this point, then the other particle right at that time, it was at its extreme position. Okay. So if this is the equilibrium position during the SHM, right? I mean to say this is the equilibrium position. So which means that right at that time, the other particle is at its extreme position. And this is exactly what I was going to show you at this place, right? So when the one particle is at extreme position, the other particle will be at equilibrium position. So this is how they will execute their simple harmonic motion. So the distance between them is, this is 0.050 meter, which is one quarter of a one complete wave. So if this is the wavelength axis, and now here I'm going to show you the angle. So in a one complete simple harmonic motion, the total angle that is covered is 2 pi, if you relate the circular motion with a simple harmonic motion, then this must be the 2 pi, and this half cycle, the half vibration represents the pi, and this represent exactly pi over 2. So that's why I was saying that the right answer is pi over 2, the option B. Last but not least, just quickly see here, when the one particle is at equilibrium position, the other particle will be at extreme position. X is equals to positive x0. When the this particle will move up because it is executing SHM, this particle will move down and its new position will be this one at equilibrium position. So that means the phase difference is 90 degrees or pi by 2.